Hi everyone. Today's video is basically kind of a replay of a talk we just gave like 1 month ago, 2 months ago at hack.lu, the principal security conference in Luxembourg, and it's about IPFS and basically how can you do OSINT on IPFS and how can you do CTI on IPFS as well. So the first part will basically be an introduction to IPFS. So it's going to be interesting to get all the big picture of the protocol. And then we're going to discuss how we can apply OSINT and CTI, so cyber threat intelligence on it. So myself, Patrick, you already know, and I was with one of my guy, Tanguy, which is the one who made basically the most research about IPFS. So let's do a quick introduction to IPFS. So it stands for Interplanetary File System. So the main idea it's a peer-to-peer protocol. So you will get multiple people that will communicate to each other. And it has been developed by FuzzingLabs and introduced in 2014. Some actual numbers, so IPFS is like 30K node annual. A lot of them are using the Kubo client, which is written in Go, and most of them are located in the US. So the really interesting part for us is basically the fact that it's a distributed file system. So there is a file stored by each different people on the network, and it's using content addressing. So the difference between content addressing and location addressing, like we usually have with HTTP and so on, is with location addressing, you have the file that is stored on a server, and when you're gonna ask to get this file back, to download this file, you will basically ask the DNS the IP of the server and then directly download it from the server. When we are on content addressing, you will basically ask for a file. This file got a specific CID, so it's a unique identifier. It's content identifier. And you're going to ask someone from the network, basically, and he will tell you, oh, okay, I don't have this file, but I know this guy is the owner of the file. He got this file available. So he will give you kind of the IP of the guy who is the one that will provide you the information. So IPFS is used by a lot of different services, of course, mainly in blockchain, but it's also used for various usage and also by really big actors. It's also used, of course, for controversial and illegal usage, like darknet forums, like for malwares and botnet, like PowerStar and IPStorm. A lot of phishing pages are on IPFS and so on. And also a lot of not safe for work stuff, of course. I mean, there is NS, FWW a bit everywhere. So to give you an example for the PowerStar IPFS variant, so it's a PowerShell malware. And as you can see in this snippet of code, there is actually a bunch of IPFS.io, gateway.pinata.cloud, and so on. So all those stuff are basically IPFS gateway. I will mention what it is later, but it's basically an easy way to access IPFS over HTTP. In the same way, we have IPStorm, which is a botnet, and in that case, the communication between the CNC and the bot are basically using IPFS. So he will send the command over IPFS, and it will all those commands will be retrieved by the different bots on that. So let's take a look on how Alice can actually upload on IPFS. So the first stuff that Alice will do with her JPEG file will be to either upload the file locally, so she will run a local node. She will, in that case, what we call pin the file. So it's basically telling to everyone, okay, I'm the owner, I have this file available. So she will calculate the CID and so on. And she will propagate to the network, okay, I have this file which is pinned, so you can, if someone want it, she can, this guy can directly ask me. Other, she can use some pinning services. So there is multiple type of them, either centralized services, so you basically upload the file directly on services online, like Piñata or Infura, which are the biggest one. Or you can even use like a decentralized service to do that, and basically you will ask to pin a file as well. So that means you're gonna ask this specific decentralized service, can you store this file for me, and you might pay for it. So let's see the IPFS upload in a bit more detail. So first you have the IPLD creation. So it's basically a structure like that. So let's take this folder, which contains HTML, JPEG, CSV, and a binary file. And as you can see, we have like a CID for the folder, and you have CID for each individual file. Once we have this IPLD structure, each file, so as I mentioned, will get this own content identifier, so the CID, and the CID will be calculated in basically different way. So it's usually like you have something like that with the multi-hash, with the codec, with also which form will be the hash content, like in that case base 58 BTC code, and so on. There is multiple version of the CID, CID v0, v1, and so on. So you can basically take a look at that using the CID inspector. But the main idea is there is a base, a version of the CID, some codec, and some content, which will be right after. For the IPLD, I mentioned, so for this folder, we have this IPLD folder, and it's basically a structure for addressable and linkable content. Each of them get the CID, and if the file is really big, it can be cut in chunks, which is really interesting because each chunk will actually get his own CID as well. So like for this one, you can see that it can be split in multiple chunks, and each one will get his own CID. So once we get all of that, so it will basically be the IPLD structure. So folder with like it's basically a set of multiple CID related to each other. We will upload that to a node. So as you remember, a local node or either like a pinning services. Once we are doing the pinning on this node, it will create records. So it will tell, okay, for each file, for each CID, I will be the owner. So as you can see, there is an ID, kind of an ID for the node, and it's actually that it's an ID for the node. And during this record creation, CID will be associated with the node who is doing the pinning. So as you can see, each individual file is associated to the same node. Then it will basically share those records to everyone he knows, to the IPFS network. The main reason for that is, in that case, each node will, as you can see, will not store the file themselves. They will store records telling them who actually detain the file. So it will share those records and they will save it, and the peer ID, it's the identity right there I was mentioning. So record is association between CID and peer ID. So they will keep the records, and if later you will see when we're gonna request a file, we will leverage on this peer ID for that. So let's take Bob that want to read a file. So if he's using a local node like that, he will get direct access to the IPFS network. So he will be able to download the IPFS get and mentioning the CID. So he will get who is the node, the PID that contain that is available that in this file and can give it to him, and then he will be able to cut this file and read the content. He can also directly use a gateway, so that's what I mentioned, IPFS communication, access to IPFS and to the content of the file over HTTP. Or you can also directly use access over a browser like Brave or Opera, which are basically either using like a local node they run themselves or either using some gateway, but it's an easy access directly from the browser. So we saw how Alice can upload, or Bob can read, and we have like a big picture of how IPFS work and how we can get access to that. What I was mentioning regarding Bob, when you will ask for the content of a particular CID, it will work something like that. It will ask, okay, can you do you have a record regarding this specific CID? So it will kind of ask for a file. It will ask for that to the first node he actually get access to. And in that case, maybe the node will reply, no, ask the node number 5, so it will even specify like the IP address of the node and so on, is closer. So what that means is, if you remember, there is an association between the CID and the PID. So what happened is, since all of them get records, if I'm asking for the CID 123, maybe in this node, the node number 1 will get his whole list of CID with PID associated, and there is kind of a matching table that exists. It's the IPFS DHT that will do some kind of matching, and the more there is a correlation between the PID and the CID, to simplify. So he's able to say, okay, usually if you are looking for the CID 123, it will be this PID that should contain the file, and so on. So he will say, okay, ask number 5. He will ask number 5, okay, can you give me, do you have a record? Do you know who is the guy that got my file? Yes, it's 7, okay, and he will ask 7, give me the file, and he will return the file content. So you can see the interaction like that. Okay, perfect. So we get the big picture. So let's see right now what can we do in terms of open source intelligence and cyber threat intelligence regarding IPFS. So the first thing we can do is actually monitoring IPFS links and CID. So you can find IPFS link in a lot of different places, from directly on the blockchain, for example, maybe some email, over email. Some people are doing like phishing or whatever, and they will send an IPFS link. There is a bunch of them you can find on Google Doc, on different websites, and so on, and even on Telegram. What is really interesting is what to learn. So if you are finding an IPFS link in the context of open source intelligence, we want to associate some metadata to it. So, okay, this IPFS link is available on the blockchain. Who is the guy behind that actually publish it? If it has been received by email, who was the email address that sent this email? In the same way, on different websites, what is really interesting is the date. When does this link have been sent or published on a forum or on a Telegram group and so on, and by who exactly? So all those information give us some kind of a context about this IPFS link and the CID associated, and it can be useful later for analysis. So an example in the wild. So for right there is a NFT, and directly on the blockchain there is this IPFS link that is written on the blockchain, and it's basically the link to the NFT profile picture on chain. So we can see IPFS, and right there we have a CID. On VirusTotal, you have a bunch of stuff that can be found, especially if you have like malware or phishing or stuff like that. A lot of people are uploading on VirusTotal, and you might get information. Typically on this one, okay, there is this URL, ipfs.io, IPFS, and the CID, and it's a JPEG image, and you might get the first time that someone requested, so it gives you some idea the date of first seen. On stuff like archive or social media, you might have some other stuff like this one. It's DTube video with this specific CID, and it's associated to this identity. So it's a user that actually upload this link. And again, another example with a Telegram channel where in that case this user actually publish an IPFS link. We can see that right there, IPFS IO and so on, and the BAFI is actually the CID. It's not CID v0, but it's another one. So we were able to associate and get metadata out of IPFS, which is really interesting because otherwise there is not that much we can find. So let's say you are doing an analysis on the IPFS phishing page. What happens if the file is actually not available anymore? So there is basically two cases. Either when you are trying to access this file and you get like a 410 censored, which means the gateway actually block the access to this malicious or restricted CID. So in that case, I will basically suggest you to run your own IPFS node and directly try to get access to the content, which will not be in that case restricted. Either you get a 504 unavailable issue, and in that case, that means multiple stuff. Either there is no more host, the hosting node is not available anymore. Maybe the file was only pinned and stored by one node, and the node is shut down right now for the moment. Or maybe even the file has never been to IPFS. It's also possible to generate the CID locally of some file, say in the record that you get this file, and maybe never upload it or make it available. It's perfectly possible. So some tips for you, especially if you at some point get access to a file and it's really interesting. Definitely use the wayback machine. Maybe especially with the gateway URL, you might be able to retrieve the content of the file, and in the same way, maybe this file is not available on IPFS anymore, but maybe you are able to find it on other decentralized services, maybe like Airwave and so on. So something else that could be really interesting is to find IPFS file variants. So let's say you have this folder, the QMQ, with different files on it, and as you can see, there is a binary which is really huge and is splitted into multiple chunks. What might happen is, let's say it's a phishing website, and what basically you are, let's say it's a phishing page for Facebook, let's say. What might happen is that the guy who actually created the phishing website potentially reuse the exact same logo for another one. And in that case, let's say this one is another phishing web page, it will, since the file is exactly the same, the CID will be the same. And in that case, you will get direct relationship between those two structures, those two phishing pages, which is really interesting for us because that means we are able to analyze this one and get direct and to get the list of who else basically reference this one. Don't forget it's like the DHT, so it will be part of his DHT and in this DHT as well. So that's really interesting, and we get actually the same for the chunk of bytes. So we have that for if it's exactly the same file, but let's say you have a malware and it's actually split into multiple chunks of bytes. Maybe you will get another variant of the malware which actually contain the exact same chunks. And in that case, we might be able to, starting from this one, to go back to which other one is referenced. So it's IPLD similarity. So IPLD is basically the structure. So based on the similarity on the structure, we're able to find variants of content, which is really interesting. Another interesting point we can actually do is to retrieve file from IOC. So especially on CTI, a lot of time you might get an IOC and it will basically be like a SHA-256, and you will need to do your own detection of malware just based on that, which is really limited. And maybe you are also looking to get like the real IPFS link to also be able to maybe detect that at the networking level. So a quick reminder, the CID actually contains the SHA-256. So you have a correlation between an IOC like a SHA-256 and the CID. So you can retrieve actually the file from the hash. So if you have a CID like that, you might be able to extract the CID, and from this CID extract the SHA-256 and get a direct idea of what is the SHA-256 of the file that is trying to be downloaded. Something really interesting is, in some cases, as you can see, the CID was this one, which is related to actually this SHA-256. And on VirusTotal, we can see that if we provide the SHA-256, we get a better detection that is a malicious file compared to if we are only taking the IPFS link. So if you are if you want to improve basically your network detection and so on, I would invite you to, each time there is an IPFS link, to analyze this CID, extract the SHA-256, and maybe do an API call to VirusTotal or to whatever security network element or CMR, whatever you have, and actually both submitted this link and the SHA-256 to get a clear overview of which kind of file is actually behind. So, as I mentioned, from SHA-256 to IPFS CID. So in that case, on Malware Bazaar, we get the SHA-256 right there. We are taking the SHA-256. We are calculating a potential CID for this one. We are getting the CID v1, and then we are taking this CID and we are trying to access the content of this file online directly using the IPFS IO gateway. And as you can see, we are getting a phishing page for Microsoft mail or whatever, Microsoft connection. So from the SHA-256, we'll retrieve what was exactly the content of the file behind. The kind of one of the final part that we didn't mention too much is in terms of networking. So we mentioned from IPFS link and CID the different kind of stuff we can do, but we didn't speak too much about the IPFS nodes themselves, which are really interesting metrics to keep in mind. So we have different nodes and peer ID, so it's the unique identifier of those nodes. So we can basically get all the peers hosting a different file using the IPFS, DHT, find a probe, and so on, and specifying the CID. We can get the identity of a peer, so it will mention, we will get multiple information like the public key. We will get of course the IP address, maybe the agent version, so we can do some fingerprinting. We will get also the different protocols that are supported, so especially like PubSub, topic, and messages, which is something I'm gonna mention later. And that's typically because of this kind of information that we are able to identify more or less how many IP storm botnet are in the wild, because that means the agent version of this one will be something particular, like a specific version agent. So we can actually do monitoring of the IPFS network using like an IPFS crawler like Nebula, and it will give you like, okay, which IPFS, Go IPFS version it is, how many agent, how many connection errors, and kind of all the different peers. You will get like direct monitoring of all the IP addresses of all IPFS nodes and so on. So some really good information if you are into CTI and especially into network analysis. So if you want to monitor that continuously, there is a multiple technique, especially for, different one if it's nodes or files. So you need to keep in mind that IPFS does not store any historical information about peers and objects. So if you monitor that continuously, you will get your own history of what happened. If you monitor the DHT, which is basically the structure of the file and so on, you might be able to know who was the first peer that was hosting the file. You might get an idea of all different CIDs that are requested by the network, which is interesting. Maybe when this CID was first seen on the network as well. You might be able to track the nodes, so it's the different people that will join and quit the network, and also the PubSub message. PubSub is something a bit particular. It's like kind of like message between peers, and it's only like something one shot that happen once and then it's disappear. So there is definitely a lot of stuff to do at both the network level, the like information regarding node communication, information regarding peer themselves, and information regarding the files that are provided over those network. So there is, in general, IPFS is really interesting. It's used by a lot of different purposes and so on. It's really interesting to understand the protocol to get a good idea how you can monitor the protocol, and also which kind of information you can get and what are the requirements if you want to do that at scale. Typically, you will need, of course, to have a lot of different nodes around the network if you want to be able to log all the information which are really interesting. So a quick conclusion and some stuff regarding the future of what we are doing. So IPFS, to recap, peer-to-peer network, decentralized, built on top of libp2p, content addressing where peers are storing the files, pinning files, and make them available and tell to everyone over via records that they are the one who get a particular CID. In terms of OSINT and CTI, it can be applied to different levels, either at the CID and links, like IPFS IO and so on, gateway links, diffusion, so monitoring where those links are used and so on, what are the file content and the structure of them, who are distributing those files, so typically the node fingerprinting, and also the global monitoring in general. How can you monitor, detect, and analyze an IPFS link, maybe without even download the file behind, and maybe directly block all the common gateway at the network level. So on our side, we are basically doing some research right now on, of course, monitoring what happened on IPFS and also on IPNS, which is the planetary name system. We are also doing some monitoring and research on the PubSub usage and the actors on that, typically regarding threat intelligence and what happened at this level. We're also taking a look at other decentralized storage network like Airwaves and Swarm. And finally, we are also integrating that into our own FuzzingLabs OSINT platform. So it's a platform that we are currently developing, which is mainly focused on blockchain OSINT. So we are our goal is to be able to pivot and to find additional information about an address or a user or maybe yeah, maybe it's maybe addresses, like you are providing us an address, and we will try to find do the anonymization and profiling and get some idea about who is the person behind. In this context, we are also adding IPFS because there is some addresses, of course, that could be related to that, and some content that could be related to that. So that's mainly what we are doing. So if you are interested about blockchain OSINT, profiling, the anonymization, and so on, in the context of, I don't know, law enforcement, compliance, or whatever, just contact us, and we will see if there is a way to do to give you access to the beta that we currently have. So thank you for listening to this. If you have any question, please use the comment section and let me know if there is anything else you would like to know about IPFS. Thank you.